No need to save.
No need to save.
No, I can't enlarge it on my TV screen so that I can connect to my.
Yes, no, you can connect, you can connect, you can connect. There is no problem. There is no problem.
I can't
Okay,
even
so
do
we will start. Hmm. So you can start. Let's start. Okay, guys. So let me record the session. If you want to share, so you can share with that. Wait 1 minute. Hello.
I'm with you.
So both are here, right? So let's begin. So core architecture is finished now. Now we are going to discuss about standalone and non-standalone. So the first thing is that we have to understand what is standalone and what is non-standalone. So this time the architecture is pretty much different than LT. Actually, here the concept is that when LT was launched, okay, so in that time they don't have the previous core network that support to launch the LT network. So LT was totally dependent on LT core network. But in the 5G, it's not like that. We have two kind of architecture that is called standalone, non-standalone. So non-standalone is concept. You can say that when any subscriber is dependent upon two different bearer, like one DRB is getting from the 5G G node B and DRB is getting from SRB is getting from the E node B. So in that scenario, we have non-standalone. So what is that? So here you can see the architecture. This is the core architecture. This is the standalone concept. Okay. This is the core architecture. Core means this is your 5GC and this is your EPC. 5G core, EPC core, 5G core, EPC core. It means it's a different concept. You can say that. So here you can see that this is the base station G node B, and this is the base station. You can see G node B. G node B means 5G base station. E node B means LT base station. So in that scenario, this is two different scenario here. So you can see the subscriber will get control plane from the E node B, but data plane from the G node B. In easy terms, like I tell you here, uh, like this is non-standalone NSA. This is my 4G and this is my 5G tower. What? This is me, subscriber. Okay. Uh, if I am getting control plane from 4G tower and I am also getting data plane from 4G tower, this kind of term we call standalone. That call standalone LT. But when I am getting control plane from here and user plane from 5G or G node B, This time of term we call non-standalone, NSA, non-standalone. Understood, Krish?
Yes, please.
Non-standalone means what? Your phone, like you have Apple phone, Apple 12, that support 5G. Okay, this phone is getting the signal from two different radio network. One radio network is G node B and one radio network is E node B. So E node B we call 4G and G node B we call 5G. So when I am getting two different radio bearer, maybe here I am getting SRB signaling radio bearer, here we are getting the DRB data radio bearer. That we call non-standalone. Standalone concept is easy. If you have 5G core that is connected to the G node B, it means your tower, and this is providing the services to the device EV. This kind of concept we call standalone. In real life also, if you are dependent on two different person, so you can say that non-standalone. But if you are dependent upon just one person, that is if you are dependent to one person. But here you are dependent to two different person, like your parents, mom and dad. So these things. So that's the concept here also. Standalone, non-standalone. So why we need it? This is the questions coming. So the base station architecture we have. So we have two type of architecture. One is called standalone and one is called non-standalone. So here we can see what are the things. So first you have to know what is base station. I know you base station means, have you seen the tower, telecom tower
Yeah, base station.
in
Yes.
USA? Yes. So those are base station. Okay. So the 5G base station we call G node B. What is G node B?
5G base station.
Yes. And also we call this term next generation node B. Okay. 4G base station we called E node B. It means evolved, because L3G was we call node B. We just add E. It means evolve node B. So 3G we called node B here. So now we have architecture deployment like a 5G non-standalone and the standalone deployment option. So here you can see that we have a core architecture. The first one we have EPC and the second one we have 5G core. So this is the standalone. So in standalone, we have two different architecture. So what are this architecture, guys? That is called standalone with EPC and standalone with the 5G. Non-standalone, we have non-standalone with EPC and the non-standalone with the 5G network. This non-standalone, we also called MRDC. MRDC means what? Multi-RAN dual connectivity. So your 5G RAN
What?
support multi-RAN. MRDC means multi-RAN dual connectivity. So your NG-RAN, it means when I'm talking about NG-RAN, next generation RAN, either it could be G node B. So NG-RAN support multi-radio dual connectivity operation whereby device is in the RRC connected state. So whenever your device is in the RRC connected state and configure to utilize radio resources that is provided by two distinct scheduler. So one scheduler may be NG E node B, or one may be NG G node B. And this two radio network is connected via non-ideal backhaul. Okay, this term we call NG-RAN. So now here we can see what we have. So the first one we call option 1, and the second one we call option 2. So we have 6 options because I make it the 6th block. So here you can see that option 1. So what is option 1? Standalone with
Standalone.
EPC. It means with EPC, it means the current scenario. Your E node B is connected to the LT, and this one via S1 interface. E node B is connected to EPC. It means this is the current LT network. This is called standalone LT under EPC. The second one we have
Option 2.
option 3.
Okay, option 3.
Option
Okay.
3. Remember this option. Remember this option. Option 3. So option 3 means what? E node B we have, and we have ENG node B. So this we call non-standalone base station. So the non-standalone base station use multi-rad dual connectivity so that we can provide throughput and data plane across the E node B and G node B. So these two are connected to EPC. So here is still the nomenclature we are using, that we use S1 interface. One E node B is connected to the G node B, that we use X2 interface. G node B is connected to EPC, that we use S1 interface. Then we have option 2. So option 2, guys, we will discuss more about this option. So option 3, this one we called. So right now you are seeing one version actually. In this one, we have 3 versions. That is called option 3, option 3A, and option 3X. So this is the options we have within the 3GPP RAN architecture procedure. So if you want to know more about that, you can follow the specs 38.801. Okay, so here in this option 3X, if you see E node B and G node B connected to the EPC core network. But always remember, in non-standalone, always remember, whoever the master, that will always provide the control plane connectivity towards the core network, and that also provide to the RAN side, and that will act as a master. So option 3 we call ENDC, that is called Utron new radio dual connectivity. So Utron is this one, new radio is this one, and dual connectivity. This is the things. And the 5G G node B here, this is called 5G G node B, and this is called LT. These two all are connected via X2 interface, the previous tech one actually. It means whatever the configuration we have to perform in ENDC scenario with the EPC, always we have to perform X2 interface rather than XN interface. So XN interface we only use when it's required to connect with the 5G core network. But in the previous day, we were using this one. Now we have option 2. So option 2 means what? Option 2 is very simple. It's not tough. So option 2, we call standalone architecture. Standalone, remember, standalone architecture. So option 2, if you see, we have G node B and we have 5G core network. Now there is no EPC core network in option 2. It means we have to provide the new core network, that is called 5G core network. And this G node B, we also call new radio. That's why we have to use here new radio air interface as well as new radio signaling protocol towards 5G core. And this new signaling protocol we call NG app, next generation application protocol. So if you see the same thing in LT, it was connected with the EPC S1 interface, but in the G node B to 5G core network, it is connected via NG interface. This is one difference actually. Here in EPC, we call MME core network, but here we have AMF that is handled for the control plane signaling within the 5G core network, and UPF that is handle the user plane connectivity for transferring the application data. So if I have two G node B, this one is connected to XN interface. So this is the one difference between LT and NR. Now we have option 4. So option 4, again, we have non-standalone. Okay. So option 4 is non-standalone means what? It means this time it is connected to the 5G core network. This is the difference actually here. So if you see the architecture is same, there is no difference. Only difference is that here EN G node B and next generation G node B is connected. Okay, guys. Give me 1 minute. I have one call. Let me pick the call. Okay, 1 minute. Am I audible? Correct. Okay.
Yes, you're audible.
Okay. So option 4, here you can see architecture is similar, right? If you see, compare with here, instead of ENG node B, here we call NG node B. Instead of, sorry, yeah, next generation E node B. Instead of E node B, it became G node B. It means master was E node B here. Now master is G node B. And E node B connected to the core network via S1 interface. Here it's connected to the NG interface. G node B is connected to the next generation E node B via XN interface, and next generation E node B is connected to the 5G core via NG interface. So what do you understand the difference? Can you tell me?
Okay.
Yeah, tell me what you understand.
Am I audible?
Yeah, you are audible.
Okay. From difference I can see here, the option one, which shows the connection from 5G lights.
No. Just tell me option 4.
Option
What
four.
you
Okay,
understand
option
in
four.
yeah. What do you understand with the option 4 and option 3?
Okay, option four and option three. In option three, we have a 4G powered base station, which will return to it connects from 4G to 5G, from 4G to 5G, and we also have the difference here that there's the powers from 4G and to 5G, but the base station is 4G base station, which return the service on the 5G network. And then option four, which is a 5G powered base station, when you transfer the new radio.
No, here, no. This is architecture. Okay, how you can deploy your network actually in the real network scenario. I told you, see, this is non-standalone. This is non-standalone option 3. This is non-standalone option 4. But here you can see that this is non-standalone LT and NR under EPC. But here you can see that this is non-standalone NR and LT under 5G core network. The first thing here, your core is changed. Earlier it was EPC, that is called Evolve Packet Core. Now it is 5GC, that is called 5G core network. Here you can see that uh, from eNode B to EPC interface. See, whenever you are exchanging any message, you cannot exchange the message directly. You have to exchange the message in some protocol or some information. In LT, we were using S1 AP, okay? But here we can use NGAP. This is what next generation application protocol. Here we are using X2 AP, okay? Here we will use XNAP. It means if I want to exchange my information, not my, the base station information between G node B to next station E node B, they have to use XNAP protocol. When they want to exchange the information between G node B to the 5G core, they only use NGAP protocol or NGAP protocol. So that's the terms. If you remember, I told you what is the interface between G node B to 5G core network. We have N2 interface, that also called N2, but N2 and N3, because this 5G core network we have two scenario. One is handle control plane. So control plane is handled by AMF and user plane is handled by UPF. So N2 connectivity to the AMF from G node B to AMF, and N3 is connectivity to the G node B to UPF. That is the terms. So that's why I'm telling you, you have to check 3GPP specs 38.801. In that one, it explained very well actually all the detail. Also, always remember, whoever handling the control plane, that will handle the master node. So here master node is this, because this is handling the control plane. Here this is your secondary node. Understood? And this option we call NADC. This is ENDC and this is NEDC. What is the meaning of NEDC? What is the term NEDC? N means new radio. Understand the term also. E means Utron and dual connectivity. Now N is coming first, so definitely N is master. G node B is master. Because N means new radio. Who is new radio? G node B is new radio. E means Utron. That's why this one. Now we have option 5. So option 5 is copy paste of LT. Only the thing is that your LT you can launch into 5G core network. But here we call eNode B, here we call next generation eNode B. Why we are calling next generation eNode B? The reason is that whatever the services we have like RRC activity, network slicing, all the things is supported by next generation eNode B, and that will come to the 5G core network. And the last one that we have option 7. So option 7 is replica of option 3. How? Jenny, can you tell me how? Kabi,
What do you say?
I said option 3 is just a replica of option 7. Are you agree with that?
Option 3 and option 7.
Can you compare? See, your eNode B, what we call here?
That's their main.
Next generation eNode B. Am I right?
Yeah.
Your EPC changed to the 5G core network. Am I right?
Mm-hmm.
From eNode B to EPC, that interface we have S1.
Mm-hmm.
But here we have NG interface.
Right.
E to ENG node B, here interface is XN.
Mm-hmm.
Previously it was X2 interface. And this is G node B to 5G core NG interface. So this is option 7 is similar to the option 3, right?
Right.
Okay, and this option we call
What?
this option we call engine DC. Engine means next generation eNode B new radio DC. So if I ask you here, who is master in option 3? Who is master node?
The master node is NMB.
ENB.
ENB.
eNode B.
Yes, this is master node. Why this is master node? Because the control plane is handled by eNode B.
Yeah.
Right. Who is secondary node here in option 3?
ENGN node B.
EN G node B. Now who is master here?
G node B.
G node B. Who is secondary node? This one.
NGE.
Who is master here?
GNB. G.
Who is master node here?
I'll say G node B. No.
Option 7.
So
NGE node
that's
B.
that G node B. That's a GN.
NG node E node B. Yeah.
Yes.
to ENB. Okay.
See, now I'll tell you the easy way. This one is master node. Why? Because NG. It means core network is connected to the this one. Core network is connected to this one, and the core network is connected to this one. But here also the core network is connected to this one. But here they are connected to AMF. Here they are connected to AMF. Here they are connected to MME.
MME.
Here they are connected to SGW. Here they are connected to EPF. Here they are connected to EPF. So AMF is handling the control part. So that's why all our master is this one. I hope the diagram is clear for you.
Yes, but can we still get this video of this thing? Because the last one you didn't give it to us.
Okay.
Yeah, the last record you didn't give it to us.
That's why I told you record yourself also so you can get it. Okay, no problem. I will share with you. So this is the things. Okay. Now, this is the architecture overview of the 5G non-standalone option 3X. 3. So here you can see multiple architecture. Okay, so here what you are seeing, guys, first understand the architecture, then we will go for that. One minute.